There are many birds around the world which spend a lot of their flying time soaring, holding their wings outstretched and spending time in a gliding form of flight. Using this method of flight, these birds can travel enormous distances using far less energy than flight utilising a constant flapping of the wings actually would. Now, some of these birds use thermal air currents or cliff faces to give them a lift, and then gliding slowly losing altitude. Others flap their wings to gain altitude between gliding periods. Now, even these birds, however, still use to have a considerable amount of energy in staying aloft. Also, rising air currents are not always easy to find, so these birds are always trying to find and eke out the smallest possible advantage in this form of flight. And there's one curious way you might actually be able to do this. It's even possible you may have noticed something a little odd about some birds, but not knowing the reason for it. The feature is most easily seen on birds like gulls and albatrosses. When these birds are on the ground, their wings are folded onto their bodies. There's a remarkable colour difference. Whilst the bodies of these birds are predominantly white or lightly coloured, the wings themselves are mostly dark grey or even black. But when you see these birds in flight, viewing them from the underside, they appear to be chiefly white again. Even the wings are now often white or lightly coloured. The reasons for this discrepancy is the top and bottom of the wings often have substantial differences in the coloration of those wings. So these, of course, why is this the case? What's the relation to gliding I mentioned earlier? Well, the dark coloration of the wings means that these wings are absorbing more of the sun's rays than white wings would. This in turn heats up the upper surface of the wing and also warms the air directly above the heated wing. This can mean the air above the wing is now a few degrees warmer than the air below the wing. The difference in temperatures between the two wing surfaces now means that the bird experiences less drag during gliding or soaring flight and can expend less energy to keep flying. Especially important for things like the albatross, as the huge size of these birds is that they're at the very limit of where flight is actually still possible. As anyone has seen an albatross attempt to take off will actually know. This effect on flying, however, might not be the only reason for this coloration on birds, especially those which spend substantial time in and around water, especially the seas and the oceans. Having dark top feathers on the top side of the wings means that whether in flight or resting on the sea, these birds blend in fairly well with the generally dark coloration of the sea when viewed from above, especially by potential predators. Additionally, the light coloured feathers blend in quite well with the clouds and the sky when viewed from below, again giving the birds a distinct advantage. The major driving force behind the coloration isn't totally clear. Now, it is possible, though, that humans may be benefiting from this colour pattern on the wings. Whether it's for gliders, drones, or even for commercial airliners, changing the colours on the wings could also possibly increase the performance of these aircraft, as well as just for birds.